Okay, so it is our last lesson on heat, and I will also mention it's the one that I always have trouble saying its name, so I'm going to try really hard. Calorimetry. Okay. Um, it is the when heat moves between substances. So we're going to take a look at what it looks like when heat starts moving around between things. So right now we've just had heat has been escaping out into the atmosphere, but what happens when we can actually see it move between substances? All right, so heat transfer. Heat energy always moves from hot to cold, okay, until the temperatures are equal. And so I'm going to give a great example. So when I was a kid, and I actually still do this, um, I every year, no matter what, no matter how much sunscreen I put on, the first time I spend more than 2 hours out in the sun, when it's nice out, when spring/summer starts coming around, I get a terrible sunburn. And so growing up, what we would do is we would sit down or lay down on the floor, and my grandmother would take a bucket of ice water and she would fill it up. She would fill this bucket of ice water or this bucket full of ice water, and she would take our towels and she would wring them. She would soak them and wring them out, and then she would lay the towels over our sunburnt skin, so over our shoulders and our arms and our legs, and then the towel would get hot. She would take it off and she would replace it with a fresh cold towel and put the hot towel back into the water to get cold again. And after several minutes of this, usually about a half hour, um, the towel would stop getting hot. It would stay cold. My skin was now cool, and while I looked like a lobster, I wasn't burning. My flesh was not burning. I didn't have a sunburn feel anymore. And the reason this works is for heat transfer. You can do the same thing if you burn your hand on the stove. I've done this where I've taken like a packet of peas and just put it on my hand. Um, I will still develop a scar and some burned flesh, but the pain, okay, doesn't occur anymore because I took the heat out. That is heat transfer. That is heat transfer. It's when you're moving from hot to cold and then everything equalizes. And so the science of measuring these changes is called calorimetry, and we use a calorimeter to capture our heat transfer. And you can make a calorimeter at home. It just a lot of them are styrofoam cups. So really, we're just trying to trap the heat energy inside. So heat is a form of energy, and again, must follow this law of conservation of energy. We looked at it before, where energy, just like matter, can't be created or destroyed. It only can transform or be manipulated. Okay? So that means that whatever heat is lost, something has to gain it. So even when we were looking at our previous math things, the heat going into the atmosphere was heating up. Okay? And that's really important. Negative Q will always equal Q, and we're going to take an important look at that in our calculations. So we can solve for this transfer by solving for the value of Q on one side and using it to find the missing variable on the other. So negative MCAT will equal MCAT. So here's the problem we're going to work through. 125 grams of water at 25.6 degrees Celsius is placed in our foam cup calorimeter, excuse me. A 50-gram sample of an unknown metal is heated to a temperature of 115 and then placed into the water. Both the water and metal will obtain a final temperature of 29.3 degrees Celsius. Determine the specific heat of our metal. Okay, so all I know is that I have to figure out what is the specific heat of the metal, which in turn could tell me what the metal is because I just said it was a piece of metal. Um, and because remember, everything has its own specific heat, using the fact that the water is going to take in some of this heat energy. Okay, so first I'm going to put down my information. So I don't know Q. I'm going to do the mass. Oh, what? Oh, sorry, that's not the right slide. Here we go. Let's try that again. Um, here we go. Negative Q is right here. So negative Q, and then we have the positive Q, because negative Q equals positive Q. Okay. The metal is going to lose, and the reason I know that the metal is going to lose heat is because that the temperature started at 115 degrees and drops to 29.3 degrees. That means it loses heat, okay? Which means my water has to gain heat. And we know that because it goes from 25.6 to 29.3, okay? It's important to understand which is which when we're filling out our table. All right, the heat energy of the metal, we don't know. We do know that it's 50 grams because it tells us in the problem. We don't know its specific heat, but we do know its change in temperature. It started at 115 and it went to 29, so it loses 85.7 degrees in this whole process. Okay. My water, I don't know Q. I do know its mass is 125. I do know the specific heat of water because it's on my table. It's 4.18. And because, here's the other thing. Remember how you have to know what state of matter this water's in? And the fact that I don't say that it's liquid, you can still figure it out. If your water is between 0 and 100 degrees Celsius, it is in the liquid form. So the fact that my water is at 25.6 tells me it's in liquid, and so I can use the liquid specific heat. Okay. And then my change in temperature is a small one. It's 3.7 because it goes from 29.3, or goes from 25.6 to 29.3, a difference of 3.7 degrees Celsius. All right, so now I have to sit here and look and say, okay, I have a lot of question marks right now. How do I know which one to go after? Well, our formula is Q equals MC delta T. Only one side has all the information to solve for a question mark, and that is this side right here. So I can go ahead and solve for this. Okay. Okay, so Q equals 125 times 4.18 times 3.7, which is 1,933.25 joules. Okay, now remember that negative Q equals Q, so I can take that 1,933.25 and plug it in to my metal side now. Okay, now I have enough information to solve for C. Okay, note that because my Q is negative, I have to put a negative sign out here. It is very important to understand that because look over here. I have a negative here, okay? And that's important because certain things cannot be negative. Mass cannot be negative and specific heat cannot be negative. So I know that at some point I need to cancel out my negatives, okay? So I'm going to take my 50 and multiply it by negative 85.7. And I'm going to take that answer and divide it into negative 1,933.25. And I get 0.451 joules per gram Celsius. That is my specific heat. That is how calorimetry works. I need to figure out either the heat given or the heat absorbed to figure out the heat released or vice versa. And I can, as long as I can figure out one set or one side, I can solve for the other. So it's just taking that Q equals MCAT and setting it equal to each other. That is everything you need to know about heat and reactions.